Okay, we're now going to look at binary ionic compounds. These are ionic crystal structures that occur between metals and non-metals, okay? And as we look at this, we'll see that there are two types of metals. Some of the metals have only one charge states, where many of the transition metals will have multiple charge states. And what we want to do is identify how we name the ionic compounds that occur between a metal and a non-metal, okay? So, these form monatomic ions. They form crystal lattices. This is not a molecule. These are three-dimensional crystal structures where the opposite charges are as close to each other as possible, and the negative and the like charges are as far away from each other as possible. And in a crystal, you have a positive cation, so the positive ion is called the cation, and you have a negative anion. The negative ion is called the anion. You must know these terms. And as I mentioned earlier, we have two types of metals. Some metals like sodium have only one type of charge state, and other metals like iron can have multiple charge states. So iron can exist as a +2 or a +3 cation, and when we name it, we have to identify which it is. So let's start with the type 1 metals, and we'll deal with the type 2 in a later slide. And what we see is that many of these we can identify their charge because they lose or gain electrons to become isoelectronic to the nearest noble gas. So if I look at the alkali metals, if they lose one electron, they have the same as a noble gas. The alkaline earths lose two electrons, they have the same. Boron, aluminum, scandium, yttrium, if they lose 3 electrons, they have the same as a noble gas. When you get into the lanthanides, it gets more complicated. Let's go back to the slide, okay? So what you need to remember is that alkali metals and silver are +1. Alkaline earths, zinc and cadmium, are +2. Aluminum, gallium, indium, scandium, and yttrium are +3. Now the non-metals are invariant, okay? Halogens and hydrogen are always -1, they gain 1 electron. Group 6 elements always gain 2, group 5 elements always gain 3. You can see that here. If we gain 1 electron, it's isoelectronic. If we gain 2 electrons, if we gain 3, note we're talking about the non-metals. We're not talking about the transition metals or the metals themselves. And the rules are real simple. You name the metal first, and you name the non-metal second, and you give it an ID ending. Now we've used the principle of charge neutrality, and so barium chloride, we know barium is +2, we know chloride is -1, so you need 2 -1s. So the name simply tells us what is the cation, what is the anion, and we give it an IDE suffix on the anion.